My perspective is going to be absolutely awesome. I've had the opportunity to see this presentation given previously, and I cannot tell you how much I enjoyed it. Obviously, it's our 100-year anniversary, and with this event, our research team went the extra distance to put their stake in the ground relative to what we think the industry is going to be looking like, shaping into the next decade or two, and what you can expect from the IBM company. To lead that discussion today, we've got Bijan Davari here with us. Bijan is an IBM fellow, and for those of you who are familiar with IBM, that's a big, big deal. So we are very fortunate to have Bijan here with us. In addition to that, he's the Vice President of Next Generation Computing. He's leading IBM's efforts to define and implement the next generation systems, employing massively multi-threaded architectures with special function engines to create workload-optimized devices. This afternoon, Dr. Davari is going to be sharing with you his insights as it relates to the future of technology, which will be shaped by the evolution of semiconductors, systems, software, and applications. Some things that have been around for quite a long time and will be around for a long time in the future. So please welcome me in bringing up Bijan Davari.
Thank you, Rich, and good afternoon. So what I'll do this afternoon is to talk about future of technology, pretty much mostly as it relates to computing systems. And one relatively unique aspect of our industry is the exponential nature of that, where both on the computing density and the bandwidth improvement, they're improving in an exponential manner, and also that goes hand in hand with the value creation. So those are things that are very different than many of the other aspects of the experiences that people have. And that exponential improvement comes from a combination of two things. One is the improvement of the existing technologies, which we all do. But very importantly, on top of that, there is a series of disruptive innovations that come one after another. And you really need to be very, very conscious and on top of that. So I'm just going to spend a second here describing why is this relatively unique. So practically almost everything that we do is measured and plotted as a function of time in a semi-log paper, which means the y-axis is a logarithmic axis. So if you were to plot that in a linear axis, which is again most of the human interactions and perceptions at the macro level are, the improvements is an exponential function, which is basically an accelerating curve. So what that means that you have to think about it like you're standing on a treadmill where the speed is constantly increasing. And that's very important. Basically what it means is if you miss a step or two, you're pretty much out. There's no whole lot of room or time to catch up. Now, another very important point that I mentioned is that smooth exponential curve is not just a simple curve that comes about, and there are many, many pieces to that. And very importantly, it's a combination of series of disruptive innovations that, when added together, really created that enhancement. So, going back to that, because of this accelerating nature, companies and or business lines get created and destroyed depending on who can catch what wave when. And as Rich mentioned, one of the aspects of IBM that we like to think about at our 100th anniversary is basically how you stay on top of that. So that's obviously pretty important. So when you think about those series of steps that are coming up, there are two ways to deal with that as far as the disruptive innovations. One is to simply create it, and then the other one is to make sure you have a reasonably good prediction of what's going to be in the future. We call it roadmap discussions. Many people are involved with that. Actually, tens of thousands of people, technical people are involved with that. So what I'm showing in this chart is just a measure of the computational density improvement as a function of time. And this goes all the way back from mechanical to electromechanical to vacuum tubes, transistors, ICs, and then so on to nanotechnology. So the important point to look at here is basically to understand that fundamentally what we do is to increase the computational density and therefore reduce the cost per computation. And that's basically what has driven many aspects of our information technology and computing system. And with that, companies have been created and some have been destroyed. So what I'm showing here is basically advent of transistor, and the reason IBM is in all of them because we've been there during all of that and managed to survive our way through it, and in some cases have some very interesting impacts on them. So, for example, on the vacuum tube to transistor transition, companies like RCA lost that business, which they were only focusing on vacuum tube. In the integrated circuit transition from transistor to integrated circuit, companies like TI were created. At the same time, companies like GE and Honeywell, which were in the transistor business, did not follow through with the IC. At the PC transition, companies like Intel and Microsoft came to being. At the same time, companies such as DEC, Digital Equipment, and Wang pretty much disappeared because of that transition was too fast. And the same thing happens continuing down the path. Right now where we are at, I apologize for the small font, so I'll spend a second on this, is this era of what we call workload optimized system, which, as you will see, it's a very interesting and important direction where you basically optimize all the layers of the hardware and software stack according to the requirements of the application. And you can think about two specific areas for that. One, enterprise, which we believe IBM is the leader, and then consumer, where Apple is. And there are some others like Oracle that would like to say that they're also playing in that area, but that's probably not a very accurate statement. At least. Okay, so with that, what I'd like to do is to do a very quick case study of a couple of these important technologies, just to ground us at where we are today and how we got here. And then that makes the projections into the future a little bit more clear.